Okay, so this is problem number 1, which is y equals x to the natural log x power. So first of all, we want to apply natural log to both sides. So it will be natural log of y equals natural log of x to the power of natural log x, and we're gonna use this rule, which is the natural log of a n of a number. It's equal to the number times natural log of a. So here, this is what we do. Okay, we use that rule. So now, imagine we have an exponent of 1 in both. So we add them, and it's natural log of x to the second power. Okay, and now we derive the natural log of y, which is derivative of y divided by y, and also we are going to use the chain rule in this one to derive it. So it's equal to 2 times natural log of x and times the derivative of what's inside of the parentheses, which is 1x. So now we're going to pass the y. It's dividing in this side, so we're gonna pass it multiplying. So here it is multiplying, and now we know that y it's equal to x natural log of x. So we rewrite it, and now we use the rule that a number and another exponent, if they have a common coefficient, then their exponents will add or subtract, and this is what we did here. So we have x, which has an exponent of -1, and we have x that has an exponent of natural log of x. So x will be natural log of x to the power of natural log of x minus 1. And there we have it. That's the answer. We keep the 2, and it's the derivative of y, it's equal to 2 times natural log of x times x to the natural log of x power minus 1. Step, we're gonna so the final step, since we don't want a negative exponents, we're gonna pass the x to as a fraction down. So that is our final answer.
My name is Gustavo, and I'm going to be explaining this function, y equals cos x to the x, which also equals cos to the x times x. Well, y equals cos times x to the x. This, as I already said, it can be represented as cos to the x times x. So the first step is to apply a generalized power rule, which would be, well, you pass the original function and you multiply times natural log times cos times x, and the exponent will come down here. So you will be multiplying the exponent with the natural log and the cos. The second step is to use the product rule on this part of the function of the problem. So this passes down equally, and you apply the product rule. So the product rule is derivative of the first term times the normal second term plus the normal first term times the derivative of the second term, which would give us derivative of x, which means this x refers to this x, times natural log of cos x, which is this part, plus normal first term, which is this x, times the derivative of this part of the equation. In the third step, we're gonna use the differentiation rule of natural log. Natural log times u times x equals 1 over u times x times the derivative of u times x. U is cos, and well, the x is the x in between the parentheses. So basically, what you're gonna do is you pass this down again equally, then you multiply this times dx, which is going to give you 1 because d times x equals dx over dx equals 1, times this, which is natural log cos x, it's the same here, plus, here's where you use the differentiation rule, 1 over ux, remember cos is ux, cos x, times the derivative, here is derivative, times the derivative of u times x, which is again ux times the x that we were using since the beginning. In the fourth step, we're gonna use again the differentiation rule, but this time of cos x, which is negative sine x. So you pass again this part equally, then you multiply 1 times natural log times cos times x, which is gonna give you this, because everything times 1 is this, plus here, this part is where you apply the differentiation rule of cos, which is negative sign. So this times this fraction, this becomes negative sin, so negative sin x times 1 is going to become negative sin x, and this x is multiplying, so it is on top on the numerator, so it's gonna move with this part of the equation. Here it is, dx, and well, you have negative sign over cos x over cos x. In the fifth step, which is the last step, you're gonna use identities. So basically what you have to do is you pass this equally, this 2, and the sign is going to change from positive to negative, because when you multiply this x times negative sign, you're going to get negative x sine x. And because the numerator, the fraction is negative, well, the whole fraction is going to give you something negative, so the sign will change to negative. And then you just multiply x times sine times x, which is this x times sine times x, over cos x. And then to get the final answer, you use identities of this part, which is going to give you this, the derivative of y equals cos to the x times x times natural log times cos times x minus x times tan times x. Tan x is the identity of sin over cos. So that's how you get to the final answer.
This is a problem number 3. We have this quotient. So we use a problem quotient that is u over b. That is b u prime minus u b prime b to the square. So our b, x squared plus 1 to the cubic, that is here. And then we have this product that is u. But when we have to derive u prime, we need to separate this process using b, u prime plus u prime times b. So when we have this sin square and tan to the quadratic, we need to derive the tan to the quadratic to 4 tan 3, because we need to subtract 1 to the quadratic, and we separate the tan. So this way we can make the process correct. So 4 goes to the first part of the process, the 4 sin squared tan cubic, and then derivative of tan is sec to the square, plus 2 tan squared sin cos, because we need to derive sin, that is we're taking the 2 out, taking negative, subtracting 1, and sin. So we derive sin, it will give us cos, minus, now it's u, the u is sin squared tan to the 4, x time, that we have this power rule. So with power rule we take a 3, rested 1, there is 2 here, and then the derivative that is inside, 2x, the derivative of 2x squared is 2x. So 3 times 2x gives us 6x sin and tan. But then the process is not all completed. We need the b squared, so we multiply this cubic to the square. Then we use greater common factor of x squared plus 1 to the square because it's the lowest power that is in the fraction, and 2 because we have equal 4, 2, and minus 6 in here you can see x. and sin and tan x, tan to the cubic. So it gives us 2 sin x sec square x plus tan x cos minus 3x sin x tan x all over x squared plus 1 to the 4 power.
Okay, this is problem number 4. We have here problem number 4. We have fx equals sin square root of 3x minus 1. So our first step is to convert the square root to an exponent. So we have u is equal to 3x minus 1 exponent 1 half. And now we have to derivate u with chain rule. And we have 1 half times 3, because 3 is the derivative of 3x minus 1, times 3x minus 1, exponent negative 1 half. And we just multiply, and that gives us an answer of 3 over 2 times 3x minus 1 exponent negative 1 half. And now we have to derivate sin. The formula of sin is sin u is equal to u prime times cos u. So we just multiply 3 over 2 times 3x minus 1 negative 1 half exponent times cos 3x minus 1 1 half exponent, and we just convert the negative 1 half exponent to a fraction, and we have 3 over 2 square root of 3x minus 1 times cos square root of 3x minus 1, and we just multiply, and that gives us our final answer, that is fx equals 3 cos square root of 3x over minus 1 over 2 square root of 3x minus 1.